Okay, so this is our generic trig or sinusoidal equation. So I'm using sine as an example, but this would apply the same thing as if I had like f of x equals a cosine b x plus c plus d. So we're going to go through each of these and talk about them, and then we're going to connect them to our transformations and then use them to answer some questions. So in our generic sinusoidal equation, A stands for my amplitude. And when you see amplitude, you should be thinking about the height of the function. Okay, one formula that you may remember back from algebra 2 is amplitude is equal to half the maximum minus the minimum. Visually on a graph, it's going to be the height, and I can find it by taking the maximum and subtracting the midline, or the midline and subtracting the minimum. Either of these would give me the amplitude. D is our midline. And when you are thinking about midline, you should be thinking about the middle. It is a horizontal reference line. B is known as your frequency. And for sinusoidal functions, B is equal to 2 pi over the period. Since we're talking about this, period is the length it takes to complete one full cycle. C is known as my phase shift. What I want to point out too here is notice how B is on the outside of my parentheses. It is always factored out. So these are all trig words, but we're going to connect them now to our transformation words, which you should already know. So the frequency of the function is the same as a horizontal dilation. The phase shift is the same as a horizontal shift or translation. Both affect the domain of the function. So remember, these are going to be referring to our x values. So whenever the question is asking about frequency or period or phase shift, those are all going to be x value numbers. We're going to be using the x coordinates to find those pieces of the function. And also it's important to note, remember that inside is always opposite. The amplitude of a function is the same as a vertical dilation, and the midline is the same as a vertical shift or translation. Both affect the range of the function. So remember, those are my y values. So if you wanted to make yourself like a little chart, domain or x value vocab words versus range or y value words. My domain, we already had frequency and phase shift. But it's important for you to know that period is also related to that. So when I'm referencing the period, It's how long or length of time. That's why it's input or x values or domain. Range, we already have amplitude and midline, but maximum and minimum are also going to be associated with range or output or y values. So that's going to be important as we read through these questions to identify what information they gave us and what information they're looking for. Example 1. The function g is defined by g of x equals a sine b of x plus c plus d for constants a, b, c, and d. In the xy plane, the points 3, -1 and 7, 3 represent a minimum value and a maximum value, respectively, on the graph of g. What are the values of a and d? So remember, a and d. A is my amplitude. D is my midline. And these both are y value pieces of information. So that means I need to pay attention to the -1 and to the 3. If you need to do this visually, you can. You can sketch out a picture if you would like. My minimum is down here at -1, 0, 1, 2, 3. That's my maximum. So if you need to, you can sketch this out. Or you can use your formula. So amplitude is equal to 1/2 max minus min. So 1/2 3 minus -1, which is 1/2 of 3 plus 1, which is 1/2 of 4, which is 2. So that means A has to be 2. Your midline is similar. It's 1/2 max plus min, or you're finding the average of the two, max plus min over 2. Maximum is 3, minimum is -1 over 2. So this is going to be 2 over 2, which is going to give us 1. So my answer is B. Visually, here's my maximum, here's my minimum. So my midline has to be in between them. So if there's 1, 2, 3, 4 spaces, in the middle is going to be my midline, which is at 1, and then my distance from here to here is my amplitude, which is 2. So visually or mathematically, either way, A is 2, the amplitude, D is 1, the midline. Example 2. The function h is defined by h of x equals a sine b x plus c plus d for constants a, b, c, and d. In the xy plane, the points 2, 4 and 4, 10 represent a minimum value and a maximum value, respectively, on the graph of h. What is the value of b? So b, remember, is the frequency, which is related to period. Both of those are x value information. So 2 and 4. Now, they told me a minimum to a maximum. Period is defined as one full cycle. So that means max to max or min to min. So if they're only giving me a minimum to a maximum, this is describing half the period. So to go from 2 to 4 is 2 units, but that's only half the period. So I need to double it to get to my full period. So that means my period is 4. Frequency, or B, is equal to 2 pi over the period. So 2 pi over 4 gives me pi over 2. Example 3. The function k is defined as k of x equals a cosine. Remember, I told you we did all sine, but it doesn't matter if it's sine or cosine. Same rules apply. So they gave me my cosine function for constants a, b, c, and d. In the xy plane, the points pi over 410 and 3 pi over 440 represent a minimum and a maximum value respectively on the graph of k. What are the period and amplitude? So period is not necessarily in my equation, but it's related to p. Remember, this is an x value or a domain. So period is going to be focusing on these pieces of information. And amplitude is a here, and that deals with y value information. So that's here and here. I think the y values or amplitude midline, those are easier to work with. So I always start with those, but it does not matter. So my amplitude is equal to half the maximum minus the minimum. So 1/2 40 minus 10, 1/2 30. My amplitude has to be 15. So choice B and choice D are automatically out. Now I need to work with the period. So to go from pi over 4 to 3 pi over 4, if you need to, you can subtract. 3 pi over 4 minus pi over 4 is equal to 2 pi over 4, which reduces to pi over 2. Because remember, for adding and subtracting fractions, I have to have a common denominator, which I do, and then I'm just working with my numerators. So 3 pi minus 1 pi gives me 2 pi. So my period is pi over 2, or my distance is pi over 2 rather, but it's only from a minimum to a maximum again. So I need to take this value and multiply by 2. So that means it's 2 pi over 2, because we multiply straight across. That leaves me with pi. My answer is choice C. All right, last one, example 4. The figure shows the graph of a trigonometric function k. Which of the following could be an expression for k of x? So this time I'm giving you the graph and we're working backwards. So you want to visually be able to identify some things. First of all, I see in my equations, they all have this -1 at the end. Remember that means I have a midline of y equals -1. And visually that's true because here is my midline in my graph. My maximum is 1. My minimum is -3. So if you needed to, you could determine from the graph, if they all had different midlines in the answer choices, you could determine your minimum and your maximum from your graph. And then visually, you could determine your midline as well. My amplitude is 2 in each of these, which is also true from the graph. My amplitude is 2. What you will notice, there are 2 differences in the answer choices. So in the answer choices, the differences are these horizontal translations, or my phase shifts, and if there's a positive versus a -2. Now, amplitude is always positive because it's a height, but the negative tells me it's a reflection. So you need to know that a positive sign starts at my midline and goes up. A negative sign starts at my midline and goes down. A positive cosine starts at our maximum, and a negative cosine starts at our minimum. So that's really what the negative in the front with the amplitude is telling you. So your amplitude, your positive or negative in front, in combination with your phase shift is going to help you answer this question. So I like to do it this way. If there's no phase shift and it's positive, that means I need to start at the origin, start at the y-axis and go up. Here, I like to use this as my starting point because that means that I would be moving. Remember, inside is always opposite. So I'd be going right pi. So I would start at pi and it would be a negative sign. This one would start at negative pi and be this negative one here. This one would start at negative 2 pi and be that one here. So what do I mean by that? Well, let's do this one first and do it in different colors. If I start at negative pi, sorry, if I move negative pi, that means I'm starting at pi. So that would be this part of my graph here. This would be a positive sign, so it's not that one. If I did this one here, I'm starting at negative pi. It would be this graph here. This graph here is a positive sign, so it's not that one. If I start at negative 2 pi, it's this graph here, and that's the graph that I'm looking for. So it's choice D. The horizontal translations can be a little challenging, but I like to use them as my starting point. So use them as your starting point, trace your picture, and see if it matches up with what it's supposed to. So those are all of your notes about writing equations from points as well as from a graph.